This is a video explanation for page 510, number 12a, which is an equation where we're trying to solve for x. This wasn't actually assigned in class, but this is a great review question as you're preparing for your test. So it's very complicated, and the easiest way for me to explain it was with a video. So we start off with this equation, 4 to the power of x plus 6 times 4 to the power of negative x equals 5. And we're going to attempt to combine the things on the left-hand side, but the plus sign makes that impossible, as well as the fact that one is 4 to the power of x and one is 4 to the power of negative x. So even if it was 4 to the power of positive x, for right here, if this term was 4 to the power of positive x, our strategy would be to factor out 4 to the power of x from the first two terms and then continue that way. But we can't factor it out because one is positive and one is negative. So there are a number of different ways you could look at solving this problem, but regardless, we're going to end up with the same sort of second half. My first thought here is to switch that 4 to the power of negative x into a positive exponent. So if we want to do that, we're going to have to write it in the denominator. And once we see this situation, usually if we have something that's a fraction and something that's not a fraction, we would like to combine those two things together, and the only way to do that is with a common denominator. So if we want to combine these two terms with a common denominator, we need to change the first term into something with a denominator of 4 to the power of x. So in order to do that, we're going to have 2 4 to the power of x's. Now we've got a common denominator of 4 to the power of x. And what we actually have here is 4 to the power of x times 4 to the power of x, which is 4 to the power of x plus x, which we could write as 4 to the power of 2x. Four to the power of 2x plus 6 over 4 to the power of x equals 5. So this is sort of where we are. Now we could move that 4 to the power of x to the right-hand side. So basically multiply both sides by 4 to the power of x, and we're left with this. 4 to the power of 2x plus 6 is equal to 5 times 4 to the power of x. It still doesn't really look like we've gotten anywhere with this question, but if you look carefully, we've now created a situation where all of our exponents are positive and nothing is left in the denominator. So we can move everything over to the same side. And now we are going to attempt to, again, somehow factor out that 4 to the power of x. And this is the hardest part of this question. We have to recognize that 4 to the power of 2x right here could be written as 4 to the power of x squared. That is using our exponent rules, that 4 to the power of 2x is the same thing as 4 to the power of x all squared. And once you get to this step, this is very similar to this expression. That what we actually have here is a quadratic. We have something squared minus 5 times something plus 6 equals 0, which is similar to a squared minus 5a plus 6 equals 0. So we can actually factor that. If we were dealing with this a situation, we can factor that into a minus 3 and a minus 2 equals 0. So in our situation in red, we have 4 to the power of x minus 3 and 4 to the power of x minus 2 equals 0. Which splits into two sections. And we can then solve for x in both of those very easy equations that we now have. So x is going to be equal to the logarithm base 4 of 3 and over here, x is equal to the log base 4 of 2. Probably helps with that middle step. There we go. So now we have a situation that we can put into our calculator. X is going to be 0.79 over here approximately, and exactly equal to 0.5 over here. Those are our two answers. Long question, not a particularly easy question, but nothing there that we don't know how to do. The trickiest spot, again, is right here, splitting that 4 to the power of 2x into 4 to the power of x squared, and remembering that factoring is a valid strategy. And there's the entire solution. Final answer 0.79 and 0.5, which you can plug back into the original equation if you want it. If you use a different strategy, you could still come up with this answer. Chances are you're, no matter what, going to be stuck with this step and going to have to use factoring in order to get the final answer.